Hello, everyone, and welcome back. I'm Mr. Cobalt, and I am going over how to balance chemical equations. I had just finished going over the first problem, and now let's go over the second problem. So the second problem is a little bit more difficult. So instead of giving you everything, they tell you write a balanced equation for the combustion of gaseous butane, and that's all they do. And so they could give you the problem and say you have the combustion of gaseous butane, and then give you more information. But here it's trickier and it expects more from you because in this sense you have to know what combustion means in order to complete the reaction and the equation. So especially the combustion of a hydrocarbon. So when you have a hydrocarbon that only has carbon and hydrogen, and maybe an oxygen as well, when you combust this, combustion means it's reacting with oxygen. That's the only way that you can burn something, because combustion means to burn something, right? And so you can only burn something in the presence of oxygen because oxygen is one of the reactants. So the only way you would know that is if you know what combustion means, right? Otherwise, they would have to tell you that oxygen gas is a reactant. Also, when you have a combustion of a hydrocarbon, the only other compounds, if it's a complete combustion reaction, the only other compounds is going to be carbon dioxide and water. And unless said otherwise, they would tell you they would tell you it's not a complete combustion. So if they don't tell you, then you can assume it's complete combustion, meaning that the only products is going to be carbon dioxide and water if you are burning or combusting a hydrocarbon. So here we have a hydrocarbon, we're burning it, it's gaseous, and so given what we know about combustion, we can figure out the reaction. They could have told us in the words in the reaction, to make it simpler, they would tell us, okay, so you're burning gaseous butane in the presence of oxygen as a reactant, and then it produces carbon dioxide and water. So they would just tell you in words, and you would have to fill that out. But this is trickier because it requires that you know what combustion is, right? So either way, we need to get the reaction or the equation for this reaction. So if it's combustion, they give us the formula, but if you remember from a previous video on the naming of your hydrocarbons, you would remember that BUT stands for 4 carbons, that you have a 4 carbon molecule, and A means you have no double or triple bonds, so it's all single bonds. So you might be able to figure it out from there. So that means that all the carbons are bonded together in a chain, and then all the other bonds are going to be your hydrogen. So, but they gave you the formula, so you don't need to worry about that. So you got your gaseous butane. So C4H10, they say gas, so we're going to write gas as the state, and then it's combustion, so the other reactant is oxygen, O2 gas. And once again, you have to make sure you know what the molecular elements are. So oxygen is one of your diatomic molecular elements, so you need to know that. Okay, so O2 gas. So we write it as O2, not O. So those two are going to react, and you're going to produce carbon dioxide gas and water. So you need to know the formulas for those. And then water, depending on your teacher, or depending on the problem itself, you can write it either as a liquid or a gas. So we can write it as a gas. Okay, so now we've got our equation. So remember, once you have your equation and you have the formulas correct, you're not going to change the formulas. So you'll remember from this problem here, once we had our formulas down for each substance, we did not change the formula. We did not change the subscripts. We only worked with the coefficients. So same thing here. We now have our formulas. All the formulas are correct. So we're not going to change formulas. We're not going to change subscripts. Never, ever, 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 ever change the subscripts once you've got the formulas. So let Taylor Swift remind you of that, okay? So now all I need to do is make sure I am putting the correct coefficients to balance the equation. Alright, so following the rules or the steps, I'm going to leave anything that is an element, a pure element, on either side of the equation. I'm going to leave that to later. So oxygen is an element, so I'm going to leave that to later. But everything else is in a compound. So carbon, oops, that's supposed to be hydrogen. This is supposed to be hydrogen. So let me do that again. So I've got hydrogen there. So I got carbon, hydrogen I'll have to do, and it looks like it. So oxygen will be later. So let's balance carbon and hydrogen. We usually, when we're balancing nonmetals, we usually balance everything and then leave hydrogen for later if it's part of a compound. So I'll balance carbon first. So I have 4 carbons here, and I only have 1 here. So what times 1 will give me 4? Or that's 4, right? So 4 times 1, let me write that better. So I have 4 as a coefficient. Notice I didn't change the subscript. So 4 times 1 gives me 4. 1 times 4 gives me 4. So now the carbons are balanced. Now I can go to hydrogen. So 1 times 10 is 10. I have 10 hydrogen. And over here I have 2 hydrogen. So what times 2 is going to give me 10? So 5. So that means I need to put the 5 as a coefficient. Notice I did not change subscripts. So I have 5 times 2 is 10 hydrogen. 1 times 10 is 10 hydrogen. So now my hydrogen and my carbon are now balanced. So I'm done with those two. Now I can go to oxygen. So I have 2 oxygen on this side. And I have 4 times 2 gives me 8. So I have 8 oxygen from the carbon dioxide. So 4 times 2 gives me 8. And then I have 5 times 1 gives me 5. So I have 5 oxygen from there. So when I add those together, I get 13. So I have 13 oxygen on this side. I have 2 on this side. So I'm going to work with this one, because if I work with this one, it's all by itself and I don't change anything else. So what times 2 gives me 13? And remember, you can do a fraction. So what times 2 gives me 13? Well, 13 halves, right? If I have 13 halves times 2 is going to, if the 2's are going to cancel out, that's going to give me 13. So 13 halves times 2 gives me 13. So I'm going to put 13 halves here. So 13 halves times 2 gives me 13. And I already calculated that as 13. So now my oxygens are balanced. So everything's balanced. My carbon, my hydrogen, my oxygen. However, I need to get rid of fraction. So since the denominator is 2, then what I need to do is multiply everything by 2. If I only multiply this by 2, then I've unbalanced the equation. So right now, as it stands right now, everything is balanced, and I don't want to unbalance it. So to get rid of the fraction and to keep my equation balanced, I need to make sure that I multiply everything by 2. So if I multiply this by 2 becomes 2. As I said, 13 halves by 2 gives me 13, so that's going to be a 13. 4 times 2 gives me 8, so that's going to go to 8. And then 5 times 2 gives me 10. So I have a 10 there. And so now you can double check to make sure everything is still balanced. So 2 times 4 gives me 8 carbons. 8 times 1 gives me 8 carbons. 2 times 10 gives me 20 hydrogens. 10 times 2 gives me 20 hydrogens. And then finally, 13 times 2 gives me 26 oxygens. 8 times 2 gives me 16, right? And then 10 times 1 gives me 10. And then 16 plus 10 gives me 26. So everything is still balanced. So that is going to be my final balanced equation. I hope this was helpful. I hope this really makes more sense and it gives you confidence to balance your equations. If you like this video, share the video, subscribe to the channel. Put a comment in the comment section and make sure that you hit the notification bell for other videos that I'll put out in the future. Thanks for joining me, and have a nice day, and I'll see you next time.